All right, guys, we're now done with fundamental trig. We've done the arc sine, arc cosine, arc tangent. We've done all the graphs. We understand the 6 basic trig functions, the reciprocals, the ratios, what a period is, amplitude. We've done all of that. Now we're actually going to get into the part of trigonometry that's actually, I think, is a lot of fun. It's actually we're going to start merging algebra and trigonometry together to create problems, and then we're going to get into real world scenarios. We're even going to get into the abstract idea, a lot of abstract ideas going forward. All right, so now this is where the time is. You're actually if you try to Google these answers, you won't even understand what you're looking at, because a lot of the websites will not give you the same type of answers that I give. Because quite frankly, for most of these, there's an infinite amount of answers. And I'm only looking for a particular few, and you've got to know which particular few I'm actually looking for. All right, so let's just kind of dive in. The first thing we're going to do is we're going to do what we call solving simple, and I'm going to do simple trig equation. The reason why I do simple is because it's really not the idea that simple implies that it's easy. Simple implies the fact that it doesn't involve trigonometric identities, which we haven't done yet. So what we're going to do is we're going to merge Algebra 1 and Algebra 2 in with the trigonometry that we already know, using the unit circle and the arc sines, arc cosines, and arc tangents. And we're going to add a couple little layers to solving equations. So I'm going to do what's called first a general solution. A general solution is going to be a way that you're going to write an equation that gives you every solution that exists, an infinite amount of solutions. So let's just start there. So I can give you an equation of -3 tangent of theta equals the square root of 3. And I want to know, what does theta equal? Well, theta, because we know from coterminal angles, there's an infinite amount of angles that could make this statement true. Well, the first thing I want to do is I want to go ahead and isolate tangent of theta. I need to isolate my trig function. So I'm going to divide both sides by -3, and I get tangent of theta equals negative square root of 3 over 3. Now here, we got to solve for theta. So what we're going to do is we're going to do the inverse operation, which is going to be arc tangent. So I'm going to take arc tangent of both sides. Well, arc tangent of tangent is just going to be theta. It's going to fall out, and we're going to get theta equals arc tangent of negative square root of 3 over 3. All right. Now from here, we've done this with the arcs. This is on the unit circle. You should have the unit circle memorized. You should be able to answer this real quick. That arc tangent of negative square root of 3 over 3 is nothing more than negative pi over 6. So we know one solution of theta is going to be negative pi over 6. Now, that's not the answer I'm looking for. If you just give me pi over 6, you're not done. That's not the correct answer, because there's an infinite amount of solutions, and this is only one. One does not mean infinite. So I need to have an equation. What I need to add is in basically the period, and how many times we want to rotate through this period. Well, tangent has a period of pi. So what I need to do is I need to do plus pi, because the same tangent is going to repeat every 180 or every pi, 180 degrees or pi, k, and then I need to say such that k is an element of the integers. And this is your general solution. That is every single answer that exists for this problem. And this is how I would expect to see your answer written. Now, I could ask you for the general solution. This part is called the general solution. But I can ask you for a particular solution. Let's say, hey, I want to have this, but I want to have the answer between, let's say, negative pi to pi. Oh, I want this to, well, I can include that. Negative pi to pi. Now, this is interval notation, so we're going to include negative pi and we're going to include pi. So what I need to do is I need to find the answers that are only between negative pi and pi. Now, here's a key. In my class, if I give you the interval in radians, you give me the answer in radians. If I give you the interval in degrees, you give me the answer in degrees. If I give you the interval in radians and you give me the answer in degrees, I'm going to count it wrong regardless of, even if you have the correct answer, because I want it in radians. Okay, so how would I do this? Well, I have to basically find every solution from negative pi to pi. Well, I have a formula here. And if I start at 0, say 0 right off the bat, I'm at negative pi over 6. All right, so that's an idea. So if I do negative pi over 6 plus pi times 0, this gives me negative pi over 6. Negative pi over 6 is between negative pi and pi. Well, if I go to 1, I'm going to do negative pi over 6 plus pi times 1, the next integer. This is going to give me negative pi over 6 plus pi, which is negative pi over 6 plus 6 pi over 6, making a common denominator. And this gives me 5 pi over 6. And 5 pi over 6 is also between negative pi and pi. Now, if I wasn't sure, I could also put a negative 1 in here and see what happens, but we'll find out that negative 1 will not be between negative pi and pi. So you can do 0, 1, negative 1, and you just got to keep plugging in numbers until you've found all the possible answers. So for the scenario when this is from negative pi to pi, my theta would only equal negative pi over 6 and 5 pi over 6. General solution, a particular solution given a restriction or an interval. So that's what we're doing. This is just a basic problem. I'm going to do another example of this of a basic problem. And we're just going to kind of build from there. This is only going to get more difficult as we go through this. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.